Okay, we will start. Okay, let's other people join when they join. Okay, now, where did we leave off? Sorry for last week. Yeah, it got disconnected and I had to go down, and then the hall was completely occupied actually. So I couldn't get the charger out. So that's why. Anyway, I was about to end the session in 2 minutes. So it's not what all the way joining again. So that's why I need to do it. Okay. I'll start with the new session today. I mean, new topic actually, the IO topic, which is pretty big actually. Uh, I think do we need to cover anything in the map actually from last week? Actually, what I was thinking, I'm just thinking. Okay. Anyway, we will do a recap later on. Okay, I will start with the IO session today, and then we'll take it from there. Okay, let me open a new one. This is the last topic in Java. Okay, from I think it will go this week, next week, and then probably it will because next week also we'll have only one session. I'm not sure next week because it all depends on this week because we are waiting for the visa to come, and then if everything goes through next week, we'll be pretty busy. From week after that onwards, right now we will do 2 sessions. We'll go back to regular sessions. Okay. Then probably from that time onwards we will start with the automation tool. Okay, automation, we'll jump into non-Java topics. Okay, so okay, coming back to the Java topic, IO. Okay, what does IO means is like, no, it's really simple. Okay, it's input and output. And again I'm just going to tell this one out again. This IO topic, right? It's really vast topic in Java. And then most of the topics, like, no, even I mean developers also won't use it actually. I mean, they will use it, but it is very specific requirement. It depends on what kind of requirement you want. Okay, so I'm going to handle this IO topic based on the test automation behavior, so that I'm just going to cover the topics which are important for us. Okay, I'm not going to go through all the just 1 second, just give me 1 minute, guys. Okay, yeah. I'm not going to go through all the concepts of the IO. Okay, I'm just going to go through the concepts which are really important for us, because the main reason is like, now if I go through the other topics, right, which is very new for you, and then it will be very confusing. Okay, once you get I'm that's what I'm going to do. Two things. Okay, I'll cover all the basics of the IO, and then we will jump onto the advanced topic of the IO, which is required basically for to do the automation. Okay, so once you get a good grasp on that one, right, then you can venture into other topics of the IO. I'll just give you a mild introduction into the other topics, okay, which are the topics which we are not going to cover. And then if you have time, or once you get a good grip on the topics which we saw, right, then you can venture into those things. Okay, I would highly recommend, don't venture into those topics until as you get a good grasp on what are all the topics we covered today. Okay, yeah. And yeah, okay, yeah, that's it. Let's see if this is going. Okay, no one has just joined. That's fine. Okay, so till now, right, we have been using IO all over the place actually. For example, right, let's open to some things. Okay, IO, just first IO. Okay. Okay, when you do this, right, system.out printer. Okay, okay, when I run this one, right, here itself is a input and output. Sorry, output is handled. So you see this out, right? That's what the output stream is for. Okay, uh, I will tell you guys exactly. Okay, what it is. Okay, so input and output, input slash output. Okay. So first topic is like, no, whole Java, right? Java is completely stream based. Okay, I will tell you what is stream and how it is used and everything. Okay, don't worry, just remember this for as the purpose now. Okay, Java is completely stream based. Okay, all Java input and output, right, everything is stream based. I will explain to you clearly what is stream, what does stream means. Okay, I'll just write this one. Okay, is stream based. Okay. Now, okay, what is the literal meaning of the stream? Think like a water stream itself. Okay, so water stream means right now what it is means right now. Say for example in a pipe. Okay, in a pipe, a stream of water is flowing through means like now what is the concept there is right. At one end, someone is pouring the water in. At another end, the water is coming out. Okay, that's a simple meaning of the pipe. A simple concept of the pipe. Okay, what you will say is like no, it's a stream of water. Okay, if you open the pipe and see what will be there, there will be stream of water continuously flowing from one end to the other end. Okay, it's as simple as this one. It's exactly the same thing here also. Rather than having the water, right? Imagine as a bites. Okay, one bite is flowing from one end to the another end. Okay, so one end. When I say one end to the other end, right? One is the source, another is the destination. Okay, so when you want to communicate with someone, okay, when I want to talk to someone, right, I will open my mouth and speak couple of words, and you will hear it in your ears, right? It's exactly this one. Okay, I am speaking the words, so I am the output stream. Okay, I am the initiator. Okay, I'm just putting the data outside. Okay, and it is being received by your ears. Okay, that's the input stream. Okay, where you are receiving the data. Okay, why they call it as a stream, right? It goes one by one. Okay, when I say one by one, a stream of water in the sense like now, say for example if you have got a tank on one end, okay, tank of water in another end. Okay, and you want to transfer the tank of water into the another tank means like no, there is two ways of doing it. Okay, either you can take the whole tank and just simply pour it into the another tank. Okay, that's one way of doing it. Another way of doing it is like now connecting a pipe from one tank to another tank and then let the water flow through it. Okay, so when you do that way, right, what happens is like now the, there is say for example there is 1,000 liter of water in one tank and there is a another tank is empty and you have connected a pipe between both those tanks. Okay, now what will happen for that, what will happen in that pipe is like now the water will trickle down in that pipe and then it will reach the other tank. So what it means is like no, not the whole tank is not transferred in a single shot into the another tank. The water is flowing through that pipe and then it is reaching there. Say for example think like if you say the depending on the size, right, say 10 ml per second or something like that. Okay, what it means is like no, the water is streaming through that pipe. That is a key word. Okay, water is streaming through the pipe. Not when you transfer the whole tank into the whole tank into another tank, right? It's not stream anymore. You're just pouring the whole thing into another one. Okay, now you understood between the difference between now you understand what is a stream means, right? Stream is nothing but it is getting a, if you want to transfer a whole bunch of data from one end to the another end, right? It means that if you, when they say I'm going to use a stream to transfer one data from my end to the another end, right, what all they mean is like no, they're going to do it in a byte by byte. They're not going to do the whole 1,000 bytes in a single shot into the another end. So what they will do is like no, they will imagine whenever someone says that word, right, I'm going to transfer a data from my end to the another end using a stream. Like now you can imagine the tank examples of tank and the pipe examples. It's exactly, it will work like that. So I will be the source and there will be a destination. I will connect a pipe to it. Okay, and then I will pour the data byte by byte so that it reaches, so that the output reader, the read in the destination, right, they can read byte by byte. Okay, stream by stream. I won't, if I want to transfer 1,000 bytes means like now what I will do is like now I won't transfer put the whole 1,000 bytes into the stream. I will send one byte and then the receiver will receive the first byte. So the second byte, third byte, it keeps on going up. Okay, that's what it's called as transferring you through the stream. Okay, just 1 second guys, I just pop out and come. Sorry for that guys. Yeah, okay, so that is what the stream means. Okay, stream is it's really simple. Okay, the data is flowing through pipe. Imagine the data is flowing through a pipe itself, but it's flowing by byte. Okay, do you guys just simply because all I'm doing is theoretical now. Okay, we will see a practical example in everything. Okay, so whenever you get a confusion about what is stream means, like it may look like a jargon. Okay, but it's just immediately in your back of your mind, think yourself the tank example, and then it is exactly like that in the Java also. The fundamental concept is this. It's as simple as that. On top of that, right, they have implemented a lot of lot of features and all those things they have done. Okay, to to facilitate. But the core concept of Java stream is right now it's as simple as this one. Okay, so someone is sending one byte into the stream and then someone is reading it from the another end. Okay, now let's rather than me doing a diagram here, right, let's open the Google and search for some diagrams. Okay, stream. Oh yeah, this is a good example. Okay, there's a diagram. Okay. So you see this diagram here, right? Okay, so it's really simple. Okay, so what does output stream means like? No, so you could output stream. So again, don't get confused yourself, guys. We have because just try to understand in the theoretical way. We'll see every example for everything. Okay, now output stream. Output stream. Okay, so we do right here. You do it right here. Okay, so this is a very simple transaction. Okay, so what is happening is like now, so someone wants to, so I'm going to try to do this also. Okay. Source and destination. Okay, someone wants to transfer some data from the source to destination. Okay, so source to destination. Okay, so what they will do is like now they will create an output stream from their end. So when I say output stream is like now they will imagine yourself as imagine the source itself as a tank. Output stream is like now I'll create a hole in my tank with the saying that okay, water can go outside via the hole. Okay, so what they will do is like now in the other end what they will do is like now they will create a hole in their end in which the data can come inside. Okay, imagine this is very important. Okay, so from the source, right, I created a hole where the water can only go outside. Water can't come inside this one. Okay, inside that hole. Okay, water can only go outside or go from out from that hole. Okay, in the destination they have created another hole from in their tank. Okay, where the water can only come inside. Okay, that's really important. Okay, because why I'm insisting on this now, in the input stream, right, you can only do the read. You can't do any write on the input stream because if it meant to receive the data means like now. Yeah. So if you meant to receive, say for example, if you meant to receive data in one stream, means you can just only receive data in data. You can't put any data in that stream. Okay. When I say you can't put any data in the stream means from that hole where it's supposed to, in the destination hole where they are supposed to read the data, right? You can't put any data in there. When I say that the reverse communication is not possible, I mean to say like you can't put data in the input stream so that output stream can read it. Okay. So strictly in the output stream, you can put data in the output stream and you can connect the input stream to that output stream and read the data, whatever they have put in the output stream. Okay, it's as simple as this one. Okay, in the output stream, usually what you will do is like now, what I said output stream is meant for, it meant for the data to go outside. Okay, so usually what you will do is like now you will write data in the output stream so that they can read data in the other end. Okay, so whoever is connected to your machine, right, whoever is connected to you, whoever is going to read the data, right, they will use a read instruction to read the data from the input stream. Okay, so I will explain to you again. Okay, so there is a source and destination. Okay, I'll explain to you in the tank concept itself. Okay, so you got two tanks. Okay, one is the source tank, another is the destination tank. Source tank is full of water, and the destination tank there is no, it's completely empty. Okay, in the source tank you're creating a hole. Okay, so that the water can flow outside, and the really important thing is like the water can only flow outside. Okay, water can't come inside that hole. Okay, and in the destination tank you are creating another hole where the water can come inside. Okay, again the same thing, very important thing, the water can't go outside that stream. Okay, water can only come inside that hole. Okay, now what you will do is like now you will connect those two holes, and then you will start to pour data in one hole, and then automatically the hole will be automatically the water will reach the another hole, where another tank, destination tank. Okay, so how you will pour the water in that one hole is, right now you will use a command called as write command in to pour data into one hole, and then you will use a command called as read command in another hole to read the data whatever you have put in the another end. Okay, it's as simple as this one. When I say output stream, in the sense like, no, the name of that hole is, right, that is called output stream, and the name of the hole which you are reading it from, right, that's called input stream. To put data in it, you'll use a command called as read command. Okay, this is just an abstract concept I'm explaining to you. I will show you a simple example now. Okay, how this works out in the Java. Okay, the Java world. Okay, now again, another important thing is like, no, this input stream and the output stream, right, it always reads byte by byte. When I say byte by byte, means like, no, you can in at a time, right, you can put one byte at the another one end, and then the another byte will reach here. Okay, you can't put 2 bytes, or you can't put 10 bytes in a single shot. Okay, so always the stream concept is, it is to flow byte by byte. Okay, there are a lot of advantages of the stream concept. Why in Java, right, all the input and output, right, everything is based on stream concept. Okay, there is a huge advantage to the stream, because the reason for the stream is like, no, it is fast, it is efficient, and then it is seamless as well. Okay, once you open these two holes, right, its connection, right, the water can flow endlessly. You can send as much data wherever there is no restriction, unless someone closes the stream. When they are done with the data, right, they can close the streams. Okay, in theoretical concept, what happens is like, no, if one stream is closed, right, automatically the another stream also will close. Okay, so you don't need to explicitly mention that, okay, please close both the streams. There are a lot of advantages in using the stream. Okay, you don't need to go dwell into that why stream is advantage, because if you want to learn that advantage in this, you have to learn the other concepts, how they do it in C and C++ or Python or something like that. So to understand why stream is why Java chose stream, and then why it is advantages over other concepts. Okay, now let's do some simple thing. Okay, you see this system.out, right? Okay, whenever I do system.out, I can't do anything here, right? Print, yeah. So this out, right, that is an output stream. Okay, actually that's an output stream. Okay, where this output stream is connected, right? Imagine again like a tank concept. Okay, this is a hole where this output stream is connected, right? It is connected to the console. When I say console, in the sense, right, console in the sense, it is the command prompt. Okay, you remember we saw an simple example on the day. Do we have a Java? I don't have any Java, I can't see. Oh yeah, I have. Just got pretty big things. Okay, you see this, right? So whenever you see this, right, system.out.println, what it means is like, no, so as I said, this is an output stream. Okay, this output stream is connected to the console. Okay, this console in the sense, right, come outside of it. So this is the console. Okay, so this has got an input stream. Okay, that output stream is connected to the input stream. Whenever you put any data in that output stream, right, it will automatically come out here. Okay, so that is the reason whenever you put anything like, I will explain to you what this println is. Okay, this output is the output stream. If you go inside this one, right, you see this, right? Don't worry about this one. It's a stream. Okay, it's a stream. Okay, if you go inside print stream, it will be extend of file output stream. So basic is output stream is the basic one. Okay, so it is an output stream. Okay, till today you have been using system.out.println, right? That out is nothing but an output stream. Okay, so what you are doing there is, right, what you are doing here is, right, this println I will explain later. Okay, this out is nothing but an output stream. Okay, so what you are doing is, right, you are pouring data into the output stream where it is being received, right? It is being received by the console. Okay, who is the console? So console is the system console. Okay, it has got an input stream. So whenever you put any data in that output stream, right, automatically system console will receive it, and then it will print it out. Okay, it will put it out. It will show it to you. Okay, so that is how the stream concept works. Okay, that's how you're getting this hello, how the hello is getting printed in the system console, right? Because Java has connected the has given you a stream which is connected to the system, whichever system you may run, right? So for example, if I open up something like sorry. And why I wanted to show you is like now I wanted to show you guys that to execute something in the directly in the command prompt. Okay. Okay, when you do this, right, you see this, right, this is a system console. Okay, you can take this program and run it in any machine you want. Okay, in a Windows machine or a Linux machine or a Mac machine or anything. Okay, you don't need to worry about anything. All you have to do is like, no, this is system.out.println, right? It is the same command for irrespective of the machine which you run in. Okay, so how does it work, right? You don't need to worry about, okay, how do I print in a Mac machine, because obviously it will change. Okay, the way in printing in Mac, right, it is different from Linux and different from Windows or whatever operating system you might be using. Okay, but you don't need to worry about it. The reason is like, no, because Java has done it for you. Okay, Java has given you an output stream. All you have to do is like, no, pour data into that output stream. Okay, Java will automatically connect that output stream to the appropriate input stream in whichever machine you are running, and then pour the data accordingly. Okay, so that is what you do. In the same way, right, you got system.out, right? There is something called system.in as well, input stream as well. Till today, to read data from the command prompt, right, we have been using scanner class, right? You can there is a lot of advantage to using scanner, but primitively, right, you can use system.in as well. Okay, let's see an example. Okay, there will be something called in, in dot, and then read will be there. Yeah, okay, if you read this, right, okay, let's look at this. One second, hang on. Why this? I think it is because of the ASCII. Yeah, it's because of the ASCII. I itself got confused why it is coming it as 2. Okay, you remember in the previous session, once long before we saw what I explained to you what ASCII means. Okay, the reason is like now, you remember what is ASCII means. Like now, when you say a in your keyboard, right? Obviously, computer can't understand a, so it has to convert into it has to convert into the binary data. Okay, so for example, the keyboard, right? Keyboard needs to tell the CPU I have typed a in the key a. Okay. So how does that communication work is right now? So A will be converted into a number format, and the number format will be converted into a binary format, and then the binary will be transferred to the CPU, because we know that all the communication, everything is binary based. Okay, it's ones and zeros in the computer. Okay, so whenever you say 2, right, it will be converted into 50. That's what the decimal. Okay, forget about the hex. Okay, it will be converted into 50, and then the 50 will be converted into binary data, and then the binary data will be sent out. Okay, so if I do this, right, I will get 2 here. Okay, again, this is bit out of topic for you guys. Okay, You don't need to worry about it. Okay, but I just wanted to tell you guys why I got 50. Okay, just don't want to say skip over it. Okay, uh, I hope you guys remember. Okay, so but if you don't remember, means like no, just remember the word called as ASCII table. Okay, and try to learn what is ASCII table and how they are used. Okay, because we don't need to go deep inside it because we have already covered the topic before. Okay, that's why it is. Okay, so it reads the character. Okay, this read functionality, right? If you look at this read inside, it basically reads the character. Okay, when I say it's a character, means like it reads the character and puts it. What I'm doing is like I'm reading a character and putting it into an integer. Okay, here why here the typecast has happened. Okay, when I say the typecast has happened, means like it is because it has read the character. Okay, if I do this, right, say for example, okay, let's do one more thing. Okay, if I type a here, you see I'm getting an A. Okay, so we know that we don't need a typecast if it's from the lower to the higher it's going. Okay, because character is smaller than the integer. That is the reason why you don't need a typecast here. Okay, so I've read something, I've stored in J, and then I'm just printing it out. Okay, that's what it is. So what is basically happening is like now this is an input stream. If I go inside this IAND, right, this is an input stream. Okay, that input stream, right, as by the concept, that input stream is connected to the console's output stream. Okay, so whatever you type here, right, it is automatically, it will be in the, it will port in this output stream, and then it will reach this input stream. Okay, so what I'm doing here is like now if you look at this, right, when I execute this program, okay, so this thing is waiting. Okay, but nothing, the program hasn't ended, because usually when the program ends, right, it will say process finished. Okay, so when I run this one, right, it hasn't finished. Okay, whenever you are reading something, whenever you put a read command, right, it is waiting. It has opened an input stream. Okay, it has connected to this output. It has connected to the command console's output stream, is connected to our input stream, which is IM, and then it is waiting for some data to come through it. Okay, so that is why it is waiting. Okay, because the read instructions, right, it will wait for something to read. Okay, because there is nothing to read at the moment. Okay, so the moment you put some data in the output stream, right, this is the console. Okay, this is the console. Okay, you put some data in the output stream, so you put some data in the output stream, immediately that flows through the pipe, and then it is available for the destination to read. Okay, so immediately the read will know that okay, there is a data available, and then it will immediately read, and then it will store it in J. Okay, so it's as simple as this one, the output stream and the input stream. Okay, till now we have been using the output stream and input stream. This is just this is just an example. We haven't gone inside any bit topic. Okay, till now I'm just explaining to you what is input stream and what is output stream. Okay, and then again, just understand an abstract concept itself. Again, we will see a bit deeper and deeper. Okay, these are all basic introduction. You might use system.out.println regularly. I bet you will never use system.in.read in your life. Okay, in the real programming. Okay, because there will never be a circumstance where you will read data from the console in the real time. Okay, and then to read data also, like you will never use system.in.read, because that's a very basic form of reading. Okay, that scanner is right. Scanner is a pretty. We'll see something scanner itself. Okay, how we have been doing. You see this, right? This is what, if you look at any of our previous program where we have used scanner. Come on. Any session. No, we don't use what the hell? No, scanner. Okay, forget about it. Just see one more. In our previous starting sessions, we might have used it.
Yeah, but I think it was in the string demo or session 8. Yeah, and no, sorry, the one above, I think. Yeah, that one. See, there is a scanner on the bottom.
Oh yeah. There. Okay, you see this, right? Whenever we do scanner, right, we always give the system.in. Okay, this is what is really important. Okay, because in the start of the session, I told you guys don't worry about the system.in, right? So now I hope you guys understood what system.in here is. Okay, the system.in, right, that represents the input stream. Okay, that represents the input stream. When I say input stream, there are some data available, going to be available in that input stream. Who is going to put data in that input stream is from the console. Console is going to put some data using its output stream, which is connected to the system.in. This is system input stream, and the console is going to put some data into the input stream, and it's going to available for it. Scanner is just a pretty okay in the system.in, right? You directly only one method was available, that is called as read. Okay, the scanner is like a helper function. Okay, imagine like a helper function. Okay, so here we are able to read only one byte at a time. Okay, as I told you before, stream, right? Stream can always read only one byte at a time. Okay, so scanner is a helpful way. Using the scanner, right, we will read a whole line. Okay, you can type multiple lines. Okay, if I do this, right, say for example, if I let's try to put some more data. Okay, if I run this, so for example, if I put this, right, it will read only the first, it will take only the first one. Okay, it will discard all those things. Okay, because it can read when you execute read command, right, it will read only one byte. Okay, it will always only read only one byte. But in the real program, right, you may want to read a whole line, you may want to read five words or 5 characters in a single stretch. Okay, because no one is, say for example, if a requirement is okay, get name of the person, means like, no, you're not going to enter the name character by character. Okay, so okay, let's implement that one. Okay, name in the name. Okay, okay, you see this, right? Okay, so this is just a, how do I say it? Okay, say for example, you want to you want to get a whole name, okay, of a person. Okay, and then if this is a kind of like a not an interview question. Okay, because this is kind of a developer's interview question. Okay, somewhat in the advanced Java, like they will ask you, okay, you have to get an input from the user. Okay, a string from the user, but you are only used to allow the read input stream reader. Okay, if they say is like, no, you can't use scanner or anything like that. Okay, only you have to use this, means like, no, this is the program you have to write. Okay, this is simple logic. Okay, so what I'm doing here is like, now I am reading a single character from the each time. Okay, I'm reading a single character from the console. Okay, one by one. Okay, and then until unless there's a simple while loop. Okay, if until unless the user has entered dollar, right, it keeps on reading. Okay, reading and adding the red character to a string called as name. Okay, and it's keep on adding it. Okay, once I enter dollar, right, it's immediately this while loop will come out of it, because the while loop will only get executed if the entered character is not a dollar. Okay, if the character is dollar, means it will just come out of it. Okay, so I have entered the name, and then I pressed dollar. It means that it has come outside, and then it has printed the whole name. Okay, don't worry about the new line characters. Okay, that's for another class. Okay, now to do you don't want to do all this cramp. Okay, all this cramp every time you want to read a string or read a multiple characters. Okay, so that is what the scanner is like a helper class which Java itself has created, because they know that you're going to have trouble. Because okay, so all you have to do in the scanner, right? So how we do the same thing in the scanner is it's a simple thing. Okay, scanner new scanner. Okay, all you have to do is like, no, you have to give an input to the scanner. Okay, if I do this, right, it will throw an error because it needs a constructor. Okay, the constructor needs an input, and then it should have at least an input stream here. Okay, so the input stream, what we are going to where the scanner is going to read data from is, that is the input stream is the system.in. Okay, that is the input stream which is connected to the console's output stream. Okay, once you do this, right, you can simply do scanner dot read line. Sorry, next line, right? Yeah, next line. This is just cheeky way of doing it. I'm just reading the whole line and then this thing. Okay, you can ask the next question. Okay, how the scanner is going to read the full line when you said that system.in, right? That the stream can read only byte by byte. Okay, it's really simple. Okay, so how it works is, right, when you run this, right, when you do this, right, so when I type this data, when I type like that, sorry, type my name, sir. Okay, when I type like this, right, so what the scanner will do is like, now once you press enter, right, what will happen is, right, once you press enter, what the scanner.next line will do is like, now internally you have used only one command to read the whole line, but internally this next line command, right, it will be reading byte by byte from the system.in, and then it will read the, when I say the whole line, right, it will read till the end, and then it will read byte by byte, and then it will, once it read the whole thing, right, then it will give it to you. Okay, it won't, because the read will read only one byte and immediately give it to you, that single byte. Okay, the next line, right, won't give you the single byte. It will wait till it will read till the end of the line, and then it will give the output to you. Okay, if you go into the implementation of the next line, right, it will they will sort of definitely use the somewhere the loop. Okay, if you go deep, right, deeper and deeper. One second. Next line pattern has next pattern clear catches. This match true result of string. So let's find with horizon. Yes. Okay, you see this, right? So I'm not going to go deep into this one. Okay, they will use a loop at some point, and they will read using the loop. They will read byte by byte, and then they will accumulate the whole byte. Okay, once they read that till the end of the line. Okay, in the Java or C or C++ or Python, anywhere, right, whenever say the end of line, right, they represent the slash and is called end of the line. Okay, so what you see is like, now you're not seeing anything, right? How the program knows it's from here onwards. I have to go to the next line. It's like, no, there is a hidden character called a slash n. Okay, in ASCII also there is a representation for the slash n. Okay, slash n, new line character, new line. There will be something called as end of text. 1 second, wait. 10 line feet carriage return. Okay, 10 is the representation of it. 10 line feet. Okay, slash n. Okay, so that is the representation. How I said that, like, no, whenever you type a, right, it transfers into 65, and 65 is transferred into binary data and goes inside. Okay, whenever you press enter, right, that's what this line feed goes. It is transferred into 10, and 10 goes to the command. Okay, so that is what. So if I open a simple notepad, right, and then I'm typing A, B, and if I type A and B, right, immediately what the keyboard would have communicated, right, it would converted the A into 65, and 65 would have converted into binary data, and that binary data would have been communicated to the CPU. Same thing goes for the B as well. So when I press enter, right, so how that would have gone is like, no, that is this 10, okay, 10 would have been converted into binary data and it would have been communicated to the user. Okay, why I'm saying this is, right, you just need to keep that in the back of your mind. Okay, it will be really useful in when you go a bit deeper into the file reading and file concepts, right, it will go, that thing will be really helpful. Okay, the new line character. Okay, so that is a hidden character here. Okay, you remember in the word, right, in the word, if you there is a way to see all the symbols. Okay, when you see all the symbols, right, you will see the slash in the word. Okay, okay, now coming back to our topic. Okay, now, so what I meant to say was like, no, this read, right, as I told you guys, right, like, no, the system.in.read, right, that will read by byte only. Okay, so you don't need to do all these things whenever you want to read a string or you want to read anything from the console. Okay, that is where the scanner class comes into the picture. Scanner, they have implemented all these concepts in a better way, so that, like, now whenever you type a string, right, it can use the system.in and read the whole thing in a single shot. Okay, that is what the scanner is do, and those are the additional topics what we are going to see. Okay, because the system.in and system.out, right, that's a simple system.in, right, that is just again a variable. Okay, in the system class, the in is just a variable. Okay, in is nothing but a variable of input stream. Okay, and then we are going to see what is input stream and output stream, okay, in depth in the class. Okay, and then there are a couple of bunch of child classes are there for this input stream and output stream, which will be really, which we will use every day in our automation. Okay, and I'm going to cover only the things which are required for our automation. Okay, now let's go to the, okay, let's type first input stream, output stream. There is something called as reader and writer as well. I will tell you what is reader and writer, okay, later. Okay, now first input stream is, right, now as I explained to you, I'm just going to write down what I explained. Okay, input stream, it's nothing but input stream used to read the data. Okay, to read the data by from a stream. Okay, now output stream is it's same thing, just to write data by to a stream. Okay, it's as simple as this one. Okay, now this byte is important difference between the reader and writer. Okay, I'll tell you why. To read a character from a stream, to write a character from a stream, Okay, first we will concentrate on input stream and output stream. Okay, now let's do some simple thing. Okay, now let's look at the what are the things in the input stream and output stream. Okay, input stream. Okay, you guys understood what is a basic concept, what is input stream and output stream in a nutshell, right? In a simple concept, right? Because we haven't still seen any practical live example, but I hope you guys who understood the simple abstract concept of what is input stream and output stream. Please guys, if you don't understand anything or any doubt, right, just ask. Okay, just interrupt and ask. Okay, I will explain to you in a better way, or simple, or any specific area which you didn't understand, right, I will explain to you. Okay, anytime interrupt, because this is really important concept for the automation. Okay, now input stream. Okay, so if you look at this, right, usually, right, input stream is the topmost class. Okay, there are a lot of subclasses. Okay, file input stream, the different types of input streams. Okay, object input stream, piped input stream, string buffer input stream. So in the nutshell, right, only thing what we are going to see for our automation, right, it's a file input stream. Okay, we are going to concentrate only on that one. Okay, so and buffered input stream also we will be seeing. Okay, so these are all the direct known subclasses. So all stream concepts. Okay, whenever in Java, right, if they use any class to read data, right, it will be a descendant of input stream. Okay, whenever I say important thing, okay, important thing is read data. Okay, the same way whenever they want to write data, right, it will, and they won't use the input stream, because that input stream is it's an abstract class. Okay, as I told you before, abstract class you can't create an object. Okay, so input stream, it will be whichever class you use to read something from the in Java, right, it will be a direct descendant of the input stream. And whenever you want to write something, whenever you want to communicate to another person, okay, so you have to create an output stream. Okay, whenever you want to communicate something to another person, right, you have to create your own output stream and ask them to connect to your output stream, and then you will put data in your output stream so that they can read it from their input stream. Okay, because imagine this way. Okay, whenever there is an input stream, right, there must be an output stream somewhere lying around. Okay, you can't have an output stream without an input stream, you can't have an input stream without an output stream, because there is no concept. Okay, so input stream is what, so imagine this one. Okay, in the tank concept itself, right, when you create a hole in your tank, right, so someone needs to be connected to that hole. Okay, so when I say someone needs to be connected, like no, someone needs to connect a pipe, and then they have to pour from that another end so that you can receive data in your end. Okay, so there should be a connection to your input stream. What that connection is, like, no, in another end there is an output stream. Okay, so whenever you want to talk to the outside world, right, you should have an output stream, and someone needs to be there to receive that output stream. Okay, if you don't have any input stream connected to the output stream, right, that output stream has got no value at all, because where the data will go, it will just, if you don't, if you have if you have two holes, and sorry, if you have a hole and that hole is not connected to anything else, means, like, no, it's just the water will just pour outside. Okay, there is no meaning to that hole. Okay, that hole in the tank should be connected to the another hole in another tank. Okay, then only that has got some meaning to it. In the same way, right, an output stream should be connected to an input stream, and the vice versa also true. The input stream should be connected to an output stream. Okay, so that you can read data in your input stream, so that the other person can put data into another stream. Okay, so if the input stream is not connected to any output stream, and then when you issue a read command, right, it is going to wait endlessly, because no data is going to come to the input stream, because no output stream is connected to it. Okay, no one is going to write data. There is no way of writing data to your input stream. Okay, so there is no one is going to write data, so that you can't read also. In the same way, the output stream also, you can put any number of data in your output stream. If there is no one is connected to that output stream, right, then it goes to waste. Okay, no one is there to read it. Okay, it's as simple as this one. Okay, so whenever you're reading something, it using any class, right, it will be a descendant of input stream, or the reader. Okay, or either it will be a descendant of input stream, or else it will be a descendant of reader. I will explain to you what reader is. It's very similar to input stream, but there is additional implementation to a reader. Okay, so main important difference between the input stream and the reader is, right now, the input stream handles in a byte, and reader is nothing but a character stream. Okay, it's a byte stream, it's a character stream. When the byte stream, okay, when you will use a reader is, like, now, if you know that the communication between you and the destination, from the source and destination, like, now, it's going to be string. Okay, it's going to be characters. Okay, say for example, you're going to type it's a chat communication, means, like, now, if it is a chat communication, is, there is only way of communication is, like, now, it's going to be strings. Okay, you're not going to put anything other than the string in a chat communication. Okay, so you will use a reader. But say for example, you want to transfer photos between one source to a destination. Okay, picture file or a executable or anything other than a text file. Okay, then it means that it is not a character stream anymore, it is a byte stream, because you can't convert a picture into a string. Okay, you can, but the best way is, like, no, to handle that picture, to convert that picture into a byte stream and send byte by byte. Okay, read one byte at a time and send it across. Okay, that is the main difference between the input stream and the reader. Okay, don't dwell into it. Okay, if someone asks, right, what is the difference between input stream and reader, right, you can just give a single answer. Okay, input stream is a byte stream. Okay, it is handled in a byte. Okay, reader is a character stream. Okay, that's what the main definition. Okay, reader versus input stream. Yeah. Okay, can I maximize it? How do we? Okay, can you guys read this one? Okay. Okay, you see this, right? Input stream is a raw method of getting information from a resource. It grabs data byte by byte without performing any kind of translation. Okay, so see here, right now, if you're reading image data or a binary file, that executable, right? Executable is executable program. Okay, that will be a binary file. Okay, then you will use the stream input stream. But if you know that it's going to be a character stream, okay, if it's not it's going to be a string, right? What you're communicating, then you can use the reader. Okay, reader is designed for a character stream. If the information you are reading is all text, then the reader will take care of the character decoding. Okay, so there is additional to it, because why they have used this input stream, right? That is the base. Okay, the input stream and output stream. Why they have created this reader and writer, right? This is later, it came in later editions of Java. When I first learned Java, right, there was no reader and writer, there was only input stream and output stream. Because why they created a reader and writer, because there were pretty much, there was so much communication going on in the Java, and then it was character based. And then, because if you want to do the character based communication in input stream, right now, you have to take one additional thing into consideration. Okay, that is called as the type of characters. When I say type of the characters, it's like, in the ASCII table, what you see is like, it's a bunch of English characters. Okay, but in the real world, right, there's Japanese characters, there is Tamil characters, there is all types of characters are there. Okay, different characters are there. Okay, when you want to handle those characters, right, you need to implement different concepts, different functionalities. Okay, so you have to do those kind of implementation by yourself in the input stream when you want to transfer that kind of communication. But in the reader, like, all you need to say what kind of character it belongs. Okay, if it's Japanese, means you can just say Japanese, then it will, the reader class, right, it will take care of all the things. Okay, but input stream, you have to do a lot of additional things to handle that Japanese character stream, or Chinese character streams, or English character streams. Okay, so that is the reason why they introduced this reader and writer. Again, it's not what will going into more into deep into it. All you need to do is like, input stream and output stream is the base for everything. Okay, input stream and output stream handles by in a bytes. Okay, in a raw byte. Okay, the reader will handle in a character. Okay, it's again, just remember it as an information. Okay, if you have time right now, just read through it. Okay, it will be pretty useful. Okay, what is reader right now? Okay, we will see all subtopics. We will see couple of subclasses of input stream, output stream, and reader and writer. Okay, which will be useful for our automation. Okay, now let's jump into the input stream. Pick up one input stream. Okay, now buffer. I need to tell you guys about the buffer stream as well. Okay, yeah. So, buffer input stream. Yeah. So, okay. See. Now, okay. Going back to that scanner example. Okay. From what I told you guys, right? The system.in, right? System.in. There is a read method in the system.in, right? Going back to the base concept. Okay. I'll type this one here. This is general stream top concepts. Okay. Sure. Okay. So stream can transfer only single byte in a read command, in a single read command. Okay, in a single, if you execute read command once, right, it will read only one byte. Okay, if multiple bytes needs to be read from the stream means, then multiple read command should be issued. Okay, so you have to execute the read command multiple times. Okay, to get multiple bytes from the stream. Okay, that's a general concept of the stream. It goes on for the input stream and output stream also. So what I mean by that, right? Now, when you issue a write command, right? Um, /write. Okay, when you issue a single read command, right, it will read only one byte. When you issue a single write command, right, it will only write a single byte to the output stream. Okay, now what is the use of the scanner is, right? Scanner is used for us to read the whole line. It is to facilitate us. Okay, we don't want to, because many people who use scanner, right, they will never know what is the concept of why they give system.in. Till now you have been using scanner, right? You never knew what system.in means. Now you got some idea what is system.in is. If someone asks what system.in means, like, no, system.in is nothing but an input stream provided by Java. That input stream is connected to the output stream of the console. Okay, so this is the console. The console's output stream is connected to this input stream. So what it means is, like, no, whenever you pour data here, right, it will immediately reach this input stream. Okay, once it reaches the input stream, how you will read the data from the input stream? You will issue a read command. Okay, but we know that when you issue a read command, right, when you issue system.in.read, it will read only one byte. Okay, but if you don't want to, because you are doing some other program. Okay, but you don't want to implement the concept of reading the whole line using the system.read that logic in your program. Okay, Java has created a class called a scanner for you, which will do this kind of logics for you. Okay, which will read the whole line for you. It will read like multiple characters for you. You can issue any kind of commands using the scanner. Okay, so there's a lot of things in the scanner, right? If you type scanner next, right, yeah, it can read float, byte, all this crap. Okay, double, long, everything. Okay, it will handle everything, but in a base, right, it will always use system.in. Okay, it's simple thing. Okay, the system.in is connected to the console's output, and in the scanner the object which you have created, right, it will use this it will use this input stream, and then using that input stream it will read the data for you. Okay, you can give any input stream. Okay, it doesn't mean that I will show you some other input streams. Okay, once at the end of the session I will use some other input stream in the scanner and show you guys how that works. Okay, now so I hope you guys understood what is system.in means. That's all I'm after. Okay, you should have a clear understanding what is system.in means. Okay, and when I say system.in means, right now in hindsight, what is in is, okay, in is nothing but an input stream. Okay, so you can go to this simple mundane diagram. Okay, what I've done. Okay, this input stream is nothing but it's connected to an output stream. There will be a source and destination. Okay, so someone is going to write data in this output stream, and then that's going to reach in the input that you're going to read using the input that is connected to the input stream, and you're going to use a read command to read the data from that input stream. Okay, it's as simple as that one. Okay, and again, you can't break this rule. Okay, in the stream, right, it will always be done byte by byte. Okay, if you want to read multiple bytes, right, multiple bytes or multiple things, now you can use the read or write command. You have to do read or write multiple times. Okay, to solve this problem, to shorten this one, right, they have introduced something called as buffered input stream. Okay, buffered input stream is nothing but a subclass of input stream. Okay, I'm going to write, so just do one space. Okay, buffered. Okay, buffered input stream is, it's a buffer input stream. Okay, when I say buffered input stream is like, no, so whenever stream is okay, it's really very close identical to scanner itself. Okay, it's available for you. Sorry. Okay, so buffered input stream, right, that's you can closely associate with the scanner itself. Okay, I'll explain to you what buffered input stream is. Okay, so input stream, we know that it reads only byte by byte. Okay, buffered input stream, right, it will buffer the data and then it will give it to you. Okay, I'll explain to you why it is. Okay, so to read data from the input stream, right, whenever you issue a read command, right, that they will call that as a costly command. Okay, when I say costly command, right, so you see this, right, if you dwell deep into the computer programming, right, whenever you issue this read command, right, what it does is like, no, this read, right, it goes and checks the input stream of which is connected to this console's output stream, and it checks whether any data is available or not. Okay, that is a costly. When I say costly, means like, no, it's how do we say that? Okay, it's a time consuming operation. Okay, it's a time consuming operation. That's why they introduce something called as buffered input stream. When I say buffered input stream, is like, no, so in the buffered input stream, if you issue the read command, right, it won't go and check the input stream which is actually connected to here. Okay, whenever you get the data, right, it's a simple thing. Okay, what is the real meaning of the buffer means like, now, say for example, buffer means it's a temporary accommodation. That's the real meaning of the buffer, right? So when you get a data in the input stream, right, so temporarily it will collect whole bunch of data and put in a buffer, and then the buffer, when you read the buffer, right, rather than reading the input stream, right, reading from the buffer is much cheaper than reading directly from the input stream, because even though in the background it is reading from the input stream, whenever a data comes in the input stream, right, that will be placed in the buffer. Okay, so I'll put it in a diagram. Okay, so okay, same thing. Okay, now, so this is the right command. This is the right command is here. Okay, whenever you do issue a read command here, right, it goes and checks in the input stream whether anything is available or not. Okay, take my word for it, it is a time consuming operation. Okay, so what is a buffered stream is like, no, buffered stream sits on top of the input stream. Okay, so whenever you issue a read command on top of it, right, it just checks the is there anything available in the buffer? No, means it will still wait. Okay, you see this read here, right? When you remember, when I issued this read, right, it was waiting for me to enter some data. Okay, it was not going over. Whenever I enter data, right, immediately this read was reading it. How it is reading it, like, no, it will continuously check the input stream. Okay, is there anything available? Is there anything available? That's a really costly time consuming operation. Okay, it might be look very fast to you guys when you see in the screen, but in the background, right, that's a time consuming operation. So how the buffer stream works, right? Whenever I take what I type here, whenever I type B or anything to it, right, it drops whenever I type anything in the console. Okay, this is the console. Okay, here it immediately goes to the input stream. From the input stream, it is transferred to the buffer stream. Okay, so what is the use of the buffer stream is, right? Okay, when you do read byte by byte, right, buffer stream and input stream is same. Okay, but imagine if the whole bunch of things. Okay, say for example, if four I'm typing 4 characters. Okay, to read the 4 characters, right, what I have to do is like, now, so I will type B. Okay, so and then press enter, and then what the input stream will do is like, now, input stream will be continuously checking. Okay, just because why I need the typecast is because read is reading in integer way. Because if we do this, right, it will have a typecasting issue. So that's why it is, because we are going from higher to lower. Okay, so higher to lower always needs a typecasting. Okay, when I execute this one, right, okay, so this thing is waiting now. Okay, it is waiting for me to type something and press enter. Okay, so what this read command is doing is like, right, it is continuously checking. Okay, is there anything? I haven't pressed enter yet. Okay, so it hasn't, the console, whenever you press enter, right, then only the console will actually take the data from here and will put it in the output stream. Okay, so what the program is hanged up, right? What what the Java is doing in the background, right? So it's the read command, right? It is keep on checking the input stream. Is there anything available? Is there anything available? Is there anything available? So once it is available, right, it is immediately printing it out for me. Okay, so that's what it is doing. So now what has happened here in the background, right? Here, right, this read command, right, it was continuously checking the input stream if there is anything available. Buffer stream, what will happen in the buffer stream when you issue the read, right? It will continuously check the buffer stream, but the buffer stream won't check the input stream, because the reason is like, now the buffer stream, right, I'm not going to go deep into the how they have implemented it. They have implemented it in an intelligent way, where how it is like, now whenever any data is available in the input stream, right, automatically it will be read and then it will pushed into the buffer stream. Okay, so when you read anything, okay, and I forgot to tell you guys this one. Okay, when you read anything from the input stream, right, it is no more available in the input stream. Okay, so again, going back to the tank concept, okay, once the data flows through that hole, right, hole in the another end, okay, from the source to destination, once the water flows through the hole, right, it is no more available in the stream. Okay, say for example, you have started flowing the water using your tank source to tank destination. Okay, now once the water flows through the stream or through the pipe and then reach the destination, right, then the water is no more available. When I say water is no more available, the water which has reached the destination, right, the water is no more available in the stream. Okay, then the new water will come. Okay, the new in the character concept, right, when you type a character, right, and when the character is read from the input stream, that character is no more available in the input stream. Okay, when you reissue the read command again, right, you won't get. That's why it will wait for a next character to come in. Okay, so do this again, right? So this is the first read command, this is the second read command. Okay, once the first read command is successfully executed, right, for the second read command to work, right, you have to enter new data. Okay, because the previously entered data, right, that has already crossed through the stream. Okay, so it is no more available in the stream to read. Okay, so for this next read command to work, right, new data has to come in from the another end, from the console. Okay, so that's what it is. Okay, so what will happen in the buffer stream is, right now, once the data comes inside the input stream, right, it will start getting accumulating here. Okay, once you type A here, right, A will come to the input stream and it will start accumulating here. Okay, the data first byte will be accumulated. Okay, when the second byte flows to the output stream, right, it will pass through the input stream and then it comes to the buffer stream and then it will get accumulated. Now 2 bytes are available for you to read from the buffer stream. Okay, imagine this one. In the input stream, there is always 1 byte to read. Okay, there will be never a situation where you have 2 bytes to read in the input stream. Okay, whenever I say 2 bytes, in the sense, whenever I say there will be multiple bytes to read, but you can't read multiple bytes in a single shot. Okay, you can read only byte by byte in the input stream. Okay, but in the buffer stream, because of this concept, right, the data gets accumulated. You can read multiple bytes in a single command. Okay, that is the major difference between the input and buffer stream. Okay, input stream and the buffer stream. Buffer stream is nothing but it is built on the top of the input stream. Okay, and the purpose of the buffer stream is, right, it is to facilitate for us so that we can read multiple bytes in a single command. Okay, and again, just by heart this by word. Okay, the read command in the input stream, right, that will read only 1 byte to you. Okay, the purpose for the buffer stream is, right, it is to handle the data in a buffered way so that you don't issue multiple read commands each time whenever you read. Okay, sorry, yeah.
Okay, Bala, what is the buffer size in the buffer stream?
Oh, that depends on the input stream. Okay, we don't need to worry about it. Okay, so whenever they do the input stream, right, okay, from the input stream, there is I think when I say it depends on the input stream, right, it will first see whether it is a byte or reader. Okay, it's a character stream. If it's a byte, means like, no, I think it can grow till 5,000 or something like that. Actually, there is no arbitrary value. I'll find it out for you, but you don't need to worry about that bit. Okay, because you don't need to worry about saying that it may have a spillover. There is nothing like that. Okay,
yeah, okay.
Imagine this way. Okay, say for example, like million bytes are available. So I have written million bytes in the output stream. Okay, so in the input stream, million bytes will be immediately available for you to read. Okay, so what the buffer stream will do is, like, now buffered stream will read like 5012 or something like that bytes and keep it in the buffer. Okay, and then because what you have to do is like, no, you have to read, you immediately for you, right, in the buffer stream 5000 bytes is available for you to read immediately. But in the input stream, right, even though there is million bytes are available, right, you can read byte by byte only. But in the buffer stream, right, immediately 5000 bytes are available to you. Once you read the 5000 bytes, right, that 5000 bytes will go away, and immediately buffer stream will read the next 5000 bytes, and it will immediately another 5000 bytes will be available for you. Do you understood the concept, Greg? Actually, just put it in a diagram.
Yes, I understand.
Okay, so I will explain it again. Okay, so say for example there is like million is too much. Okay, say for example there is a 10,000 bytes is available in the output stream. Okay, I have typed 10,000 characters in the console. Okay, now immediately 10,000 characters will be available for the input stream to read. But to read the 10,000 characters, I can't read all the 10,000 characters in a single shot. I have to read character by character. Okay, what the buffer stream will do is like, now buffers will, there is a limit to the buffer stream. Okay, buffer size, that's what Greg asked. Okay, so the buffer stream will read like 5000 bytes and store it in its own buffer. Okay, so that immediately for the buffer, whoever uses the buffer stream, right, they can read immediately the 5000 bytes. Okay, in a single shot, in a single command, they can read the whole 5000 bytes. Once the 5000 bytes is read, right, buffer stream will go and check input stream, is there more data is available. Yes, because there will be more data will be available, because the total available data is 10,000 bytes. It will read the next 5000 bytes and keep it in the buffer, so that immediately for the next command, right, when you issue the next command, right, it can read the next 5000 bytes. Okay, now the difference between the input stream and the buffer stream, right, to read the 10,000 bytes, you would have issued 10,000 read commands, but in the buffer stream we issued only two read commands. That is the main difference between the input stream and the buffer stream. Okay, imagine this buffer stream, right, in the real time, and it acts just like a buffer for the input stream. Okay, so it will collect the data from the input stream and keep it in its own buffer, so that for us to read the multiple bytes at the same time. Okay, that is the only purpose of the buffer stream. Okay, buffer stream.
So you always need to go from output stream to input stream and to the buffer. Can you go from output stream straight to the buffer stream?
Oh no, you can't. No, you can't. Always imagine, okay, the output stream, buffer stream can't work individually. Okay, buffer stream is nothing but on top, it works on top of input stream. Okay, so this is the core. Okay, anything, the scanner or any kind of class you use, right, this is the core. Okay, output stream and input stream is the core. Okay, even for this reader and writer, right, you won't see this directly, but in the background, right, output stream and input stream is the core. Okay, that is the only way of communication that can happen. Okay, all the other things, whatever we are going to see now or in the later session, right, they are all just built on top of it. You will see it. Okay, so whenever scanner is a very good example. Okay, scanner is one of those kind of like better way for us to doing it. Scanner can't operate on its own. Scanner is a class. Okay, or can't operate on its own, because for the scanner, right, you have to give an input stream as an input. Okay, this if you look at this IN, right, IN is nothing but an input stream. Okay, input stream won't have any kind of parent class. Okay, implements closable is nothing. Okay, input stream will be the top class for all the things. Okay, if you see here, right, see here, so it is the top for all the thing, all the stream concepts. Okay, and then if you go to Java, that input stream, yeah, here it's a very simple. Okay, input stream will sit on top of everything. Okay, in the same way output stream will sit on top of everything. Okay, output stream will sit top of everything. Okay, and there will be a lot of other classes. File the same way, where how I told you file input stream, we are going to see the file output stream. Okay, output stream will sit on top of everything. Okay, and then what I was explaining. Okay, and then if I look at the buffer input stream, right, okay, if you look at the file output stream, right, that is a very good example. Okay, that is a very good concept. Okay, so output stream, right, in a constructor, you look at any of these constructors. Okay, any of these classes. Okay, file output stream or any of these classes. Okay, the constructor, right, it won't have an empty constructor. You will yeah, it won't have an empty constructor. Okay, but the output stream, right, it will have an empty constructor, because that doesn't need anything to work. That doesn't work on any top of anything. It works on its own. Okay, output stream. Okay, but for all the subclasses to work, right, it has to work on top of something. Okay, so in the same way, if you look at buffered input stream, right, when you want to create an object for the buffered input stream, right, you can't create a constructor. You have to create it on top of an input stream. Okay, you can't create it on its own. Okay, so yeah, you asked, right, we can give the size by our own, or else it can take the default size. Okay, I can find out the default size. Do you have the given it here? Okay, now I can find out the size for you, okay, later on. Okay, but buffered input stream or buffer output stream, right, it can't work on its own. Okay, so this buffer stream to work, right, oh sorry, buffer input stream, here it is input stream, buffered input stream, in the same way, right, you can. Okay, it's as simple as that. Okay, so the same purpose serves here itself. Rather than for you writing one byte at a time, right, in the output stream, right, you can write, you can issue a command saying that, okay, can you write this, using the output stream, right, you can't issue a command saying that, can you write this like 100 characters into the output stream. But using the buffer stream, right, you can do that. Using the buffer stream, whenever you issue, can you put this 100 characters into the output stream, right, buffer output stream will do the job of issuing multiple write commands, so that each command, each character, whatever you have mentioned, that 100 character, right, that goes to the output stream. Okay, it's exactly the same as the input stream. Okay, so rather than do in a simple concept, a simple sentence, right, output stream, you have to do it in a byte by byte. Okay, whenever you use a buffer output stream or buffered input stream, right, you can handle and do it in a buffered way. What it means is, like, you can do multiple bytes at the time. Okay, that's what it is. But in the base, right, it is again a single byte. Okay, you can't go over the topic. It is just a clever way of implementing. Okay, so that it doesn't look for you that it is doing byte by byte, but in the background it is actually byte by byte communication only. But it happen it if you use buffer input stream or buffer output stream, right, it will look like it is happening multiple chunks of bytes at a single shot, but in the background it is single bytes at a time. Okay, it is just a clever way of implementation, same like scanner. Okay, um, where, here. Okay, now I'm just going to, that is what the buffer input stream and buffer output stream means. Okay, that is the difference between the input stream and output stream. Why I told you so much about the buffered input stream, right, that is because for me, right, whenever I do the automation, right, I need a when I because you will never see any of this buffer input stream or buffer output stream whenever I do when there is a very whenever you do a file read or file write, right, you will never see any of these things. But in the background, right, it will use all these things to do that operation. The reason why I told you all these things is, like, now, because you need to know whenever I can write in a, okay, I'll show you guys in a pretty simple. Okay, so okay. Shall I use buffer stream? I'm going to read this file itself. Okay, copy path, yeah. Second, oh, Cannot be null. Yes. I think it's called EOF for oh, okay, let's do it in a different way. This will result in an exception, but it will print out the whole thing. I'm just printing out the whole count words this class. Okay. Something happened to my system. Okay, basically you guys saw this one, right? It has printed out this command, right? It has read the file called just one moment, guys. Was it got hanged or something like that? Okay, basically what has happened is like it has read the whole this file, okay, this count words file, and then it has printed it out. Okay, so again, whenever you know that it is going to be a text file, right? Because count words is nothing but basically a text file, okay, even though it's called java, it is nothing but a text file. Okay, whenever it's a text file, right, you can use a reader. Okay, you can use the input stream also to do the whole thing. Okay, this is one way of doing it, but using the reader, right, there is a much simpler way of doing it. Okay, whenever you do the reader, right, basically this is what happening in the background. Okay, sorry, basically that is what happening in the background. Okay, but you need to know what is input stream, what is output stream, because you will come across those words input stream and output stream a lot, and then sometimes you will see something called buffer stream and buffered output stream. That also you will see a lot. Okay, so this is one way of doing it. I'm just going to show you guys how to do it in the reader. Okay, it's very identical to the stream. Okay, you see, I'll just replace the input stream to reader. Okay, that's it. I won't, it's exactly the same thing. Okay, oh, okay, the while is a true. Oh crap, that's why it hanged. Okay, it was a true statement. Okay, it became an infinite loop. That's why it got hanged. Okay, that was my mistake. Sorry, guys. Okay. Now, okay, you see this, right? I can read by character in the input stream. Okay, whenever I do the input stream. Okay, but using the reader, right? Let's see. I can do a string. You see this, right? Something called as read line is there. Okay, if you do let me do this. This is a simple example. Okay, now going back to this one. Okay. Here, what I told you, right? It's okay. It's as simple as this one. Okay. Now, just output stream has been replaced with writer. Input stream has been replaced with reader. The reason why I'm going to concentrate on the reader is like now because in our line, right, most of the time where you really use the automation to file read and file right, it will be the log files or write the report or something like that. Okay, some kind of information. Okay, so in most of the circumstances, right, buffer reader and buffer writer will help you in hand. But in circumstances where you want to handle the photos or else some kind of executable or some kind of binary data, right, there you can use the buffer output stream or buffer output stream. It's simple. Okay. Now, if you look at this, right, file reader, right, imagine this file reader, right, that is nothing but a simple reader. Okay, file reader is nothing but a simple reader. Okay, it's a type of a reader. Okay, it's exactly like a reader. Okay, file reader, imagine, think this. Okay, file reader is nothing but the another type of reader. Okay, if you look at the file reader, right, it will be built on the reader concept itself. Okay, file reader Java, it will be a descendant of reader. Okay, now you see this, right? This is another very good example. Okay, reader, right, usually whenever you open any class, right, buffer input stream, right, they will have their own methods. Okay, this method summary, what this method summary means, like, no, that is the method that are defined inside this buffer input stream. Okay, and then it will inherit some methods from the parent class. So if you look at this, right, buffer input stream is a child class of file input stream. File input stream is a child class of input stream. Input stream is a child class of object. Okay, so all the methods available in object will be available in input stream. All the methods including input stream and object will be available in the filter input stream, and all the methods available in those three classes are available in the buffer input stream. That's what it has been explained here. Okay, what are class it got from input stream, filter input stream? What are the class it got from object? Okay, now whenever they say this kind of method summary, right, it is additional things that are available individually in the buffer input stream. But if you look at the file reader, right, it is a descendant of input reader. Okay, it is a descendant of input stream reader, and then input stream reader, in turn reader, and then object. Okay, but there is no individual method summary, because all it has got is like now bunch of methods that has inherited from its parent. Okay, it doesn't have any reader of its own. Okay, the reason for it is right now you can simply say file reader is another type of reader. That's it. Okay, it's a simple thing. File reader is another type of reader. Okay, now buffer reader, right, I told you guys before itself, right, buffer reader can't work on its own, the same way how buffer input stream can't work on its own. Okay, it has to work on top of an input stream. In the same way, buffer reader, right, it has to work on top of a reader. Okay, now what we are doing is, like, now I am doing a file reader. Okay, so file reader is nothing. I have created an object for file reader, new file reader. I will explain to you what this file means, okay, later on. Okay, so if I open this, if I see what are the one second, I think I missed that. Yeah, if I open the thing, right, there is no read line is available for you. I can read character by character. It will read a single character, and then I can read a single character array, all those things. Okay, there is no option for me to read a whole line in a single shot. That's where the buffer reader comes into the picture. So if I give buffer reader, if I give this file reader which I have created to the buffer reader, and if I do the buffer dot, right, what are the methods available, right, this read line, right, this is the most important thing which we will use. Okay, so I will show you guys how I do whenever I want to read a file. Okay, any file. So this is how I read a file simply. Okay, this file and statement. Okay, I know this by, I mean, I've done it so many times. That's why I can remember so quickly. Okay, so the reason is like now you can also by heart this way and then do all the times whenever you want to read a file, right? You can read using this command, but you need to know what this file reader does, what this buffer reader does, why you need to give this file reader to as an input to the buffer reader when you create an object, and why you have read line in the buffer reader but why you don't have a read line in this reader. Okay, there is a reason for everything. Okay, f4 dot. So why there is no read line, or why there is only read to it. Okay, there is a reason for everything. That is the reason why I went deep into that, what is input stream and why there is a buffer input stream. Okay, because these 5 lines, right, this is 6 lines is only you're going to use every time. You're not going to use anything else. Okay, this once you understand this concept, right, you don't need any other mechanism. There is lot of mechanisms to read a file. Okay, this is the simplest way to read a file, but you need to know every word in this one. Okay, why, meaning of it. Okay, what is file reader means, what is buffer reader means, why you're giving this input, why you're doing this read line. Okay, so if I execute this one, right, you simply read the whole class, whole thing for me. Okay, see, it has read the whole thing, whatever in the count word. Okay, this is how we will read a file. Okay, I think I have to end the session today now. Okay, so in the next session, right, we will see something about the print writer. Okay, we will see deep into the output stream. Okay, now as an advice, right, okay, just go and read about what is input stream and output stream. Okay, don't forget about the buffer. Okay, what is input stream and output stream, what is reader and writer. Okay, just these four alone. Okay, input stream and output stream, what is reader and writer. Okay, how they are used. Okay, if you have time, right, read about the buffer stream also, why the buffer was introduced. Okay, now then we will, because we have seen till now only the abstract simple theoretical concept. Okay, now I will implement couple of other examples. Okay, regarding the buffer input stream, we will try to copy an actual photo, because this is a text file, this count word is a text file. We'll actually try to copy a picture across. Okay, and see how it works, and then we will do an example of like, no, how we'll try to use a HTTP call and then download a Google or download a actual HTML file. Okay, and see how that works in the upcoming sessions. Okay, so just as homework, right, just read about the input stream, output stream, reader and writer. Okay, I will upload this session later on. Okay, probably tomorrow morning. Okay, and then you can go through it one more time. Okay, okay guys, I'm going to end the session now. Okay, I will probably again coming back to next week. Okay, next week Wednesday I should be all right, but depending on this week, right, I will tell you guys how if we can do the Wednesday session or not. Okay, or else, right, like if I can't do the Wednesday session, then we can do regularly from Monday and Wednesday onwards, from the next week, following week onwards. Okay, okay guys, I'll see you guys next week hopefully. Okay, bye.
All right, cheers. Bye.